For our first set of problems on tonight's homework, we're just asked to find the domain of the function. So that's for, let's see, that's for 57 until 66. It's more for myself than for you. Okay, so I'm just going to draw a little line down here so I don't keep just doing domain. So just domain for these. Domain, remember, is the set of all x values that can be plugged into the function without getting an imaginary number or something that's undefined. So our first couple are pretty easy. The domain for a quadratic, all real numbers. Domain for this quadratic, all real numbers. So polynomials, linear, quadratics, anything higher degree, polynomials, all real numbers. These are domains. 59, we have a rational function. The variable in the denominator can't equal 0. I'm going to use interval notation for my domain. So we can plug in any t value except for 0, so negative infinity to 0, 0 to infinity. For this rational function, the numerator does not matter. The 5y is irrelevant. It's just that the y plus 7 can't equal 0, which means y can't equal negative 7. Y is the domain in this section, in this equation. So the domain is negative infinity to negative 7 to infinity. Oh, and should we be using set notation in here? I guess probably technically yes. It really does not matter. Our textbook, if we were using an online version for our textbook, it would count it wrong if you put the set notation in there. So it just kind of depends. But you can put that in if you want to or not. I'll take either one. For 61, this is a square root function. The expression underneath the square root needs to stay greater than or equal to 0, which means y should be anything greater than or equal to negative 6, which means I use a square bracket for negative 6 and take it out to infinity. That was the rule for square root. It's actually the rule for any even root. So I'm taking x squared plus 3x, setting it greater than or equal to 0. Now, be careful on 62. You cannot just factor out an x and say, oh, x should be greater than 0 or greater than negative 3. That's not how that works. Instead, you do get those zeros. You put those zeros on a number line with closed circles because we're allowed to hit 0. And you think about what this graph would look like. So not the fourth root graph, just the x squared plus 3x part, just this expression. This is some sort of parabola that opens up, and these are its two zeros or x-intercepts, right? This number line is the x-axis. And so what we're saying is the graph is above the x-axis, anything to the left of 0. The graph is below the x-axis between 0 and negative 3, and above the x-axis to the right of negative 3. So we want just the positive sections. So our domain is anything from negative infinity up to and including 0. And anything from, oh, I put these in the wrong order, didn't I? Goodness. Negative 3 is definitely to the left of 0 on the number line. Okay, but still the same conclusion. So it would have been wrong if I would have answered negative infinity to 0, because that includes a chunk that's not in there. So negative infinity to negative 3 and 0 to infinity. I'm kind of glad I made that mistake though, because that is pretty common to accidentally mix up your numbers like that. All right, what about our next one? We don't have to bother getting a common denominator here. We can just say, well, I can't have this fraction be undefined and I can't have this fraction be undefined. Getting a common denominator would just give you an expression in the top of the fraction, which doesn't matter for domain anyway. So x can't be 0, and it also can't be negative 2. Make sure when you're writing interval notation, just like the last one, that you put this in the order of what number you would hit first. Negative infinity to negative 2, not including negative 2. Anything between negative 2 and 0, and anything from 0 to infinity. Those are the three chunks of the domain. And 64 is kind of the same thing. We can factor the denominator out a little bit. Since this is a rational function, the denominator can't equal 0, so that means x can't equal 0 or positive 2. So same idea, start at negative infinity for the domain and take it up to 0, not including 0. Anything between 0 and 2 is fine. And anything from 2 to infinity. Okay, 65 is both rational and has a square root in the denominator. So normally the square root rule is set the expression greater than or equal to 0. But if the square root is in a denominator, you're only setting the expression greater than 0. We don't want it to equal 0. So y has to say greater than 10, and the y plus 2 is irrelevant. So the domain for this one is not including 10 out to infinity. And then for 66, if the square root is in the numerator, this is the only time the numerator matters, we have to make sure that x plus 15 remains greater than or equal to 0, and we also have to make sure that 15 plus x is not equal to 0. So here we're saying x can be anything greater than or equal to negative 15, but then this is saying, well, x can't equal negative 15. So merge them together, that's just saying x needs to stay greater than negative 15. So negative 15 to infinity. And then for this next section, I believe we're doing domain and range. Yep, so it says use a graphing utility to graph the function, find the domain and range. So I don't, wait, do I want you to do that? Let's see, to 72. I don't want you to use a graphing utility. You can if you want to check things, but we should be able to reason through these. Well, actually, domain we should be able to do, but range maybe calculator for some of these. Let me check my answer key to see what I did. Oh no, I did do these without, didn't I? All right, let's try it without. This is a graph that we will see a lot. I want to make sure you know it. You'll see it in calculus next year too. The square root of a difference of squares, where it's a perfect square, where it's a number minus x squared, is a half circle. So it's the top half of a half circle. So if we sketch this graph, if I plug in 4 for x, I get 0. If I plug in negative 4 for x, I get 0. If I plug in 0 for x, I get square root of 16, which is 4. So it forms this little half circle here. So what's the domain and range? The domain is anything between negative 4 and 4. Nothing outside of that, because start plugging in 5 and you get square root of a negative. The range is anything from 0 to positive 4, with a bracket, but nothing outside of that range either. So know this graph, study that. Anytime it's the square root of a difference of squares and the x squared is second. Square root of the sum of a couple of squares here. Well, let's think about this. We need to make sure x squared plus 1 stays greater than or equal to 0. Well, it always is, right? X squared is always greater than or equal to negative 1. Think about that graph, x squared plus 1. So the domain is all real numbers. We can plug in anything we want to this domain, and we'll get some sort of y value to come out. The range, the y values are not all real numbers though, because like I just showed, the domain, if you plug in 0, you get this minimum of 1, and then anything you plug in after that, the numbers get higher than 1. So the lowest y value on here is the square root of 1, and then they just keep increasing after that, right? So the range is 1 to infinity. Now, you can use a graphing utility to confirm with these if you're kind of checking on your own. Or if you're doing more problems than what I've assigned on the page, you could also use the graphing utility or Desmos to double check. We should know about absolute value graphs. So an absolute value graph that's got this 2x plus 3. We haven't talked about, I don't think we've talked about horizontal dilations and shifts and all of that, but this is a horizontal dilation by a factor of 1/2. It just means, what does that mean? It just means this graph has been shifted left and it's got a steeper slope on both sides. What's the domain for that? All real numbers, or negative infinity to infinity. What's the range? Well, we're never going to get anything negative, so we can go from 0 to infinity. Same thing with this absolute value of this linear function. We don't need to know about the translations and stuff yet. We can really just say, it's some absolute value graph that again got shifted. The only thing that's important is if there's ever like a negative to make the thing open down out in front. But this domain is all real numbers, and this range is still 0 to infinity. Okay, these are our last two for this domain and range section. For the domain on this one, x needs to stay greater than 0, so 0 to infinity, because I can't actually be equal to 0 down there. X minus 4 doesn't matter for domain. And then what about the range? So I always run through this list of questions. Can I get y equals 0? Yes. If x equals 4, I get 4 over square, or I get 0 over square root of 4. That's 0. So yes, y can be 0. Can y ever be less than 0? Can y ever be negative? Well, the the absolute value of x, the square root of x is kind of like an absolute value where it's always positive, right? You can't square root something and get a negative to come out if we're talking about real numbers. So the bottom will always be positive. Can x minus 4 be negative? Well, again, we're restricted to x greater than 0, so let's just start here. If we plug in 0, we get negative, well, we can't plug in 0. If we plug in 1, we get 1 minus 4 over square root of 1. That's negative 3 over 1. So yeah, x can be negative, and y can be negative. And can y be positive? Yes, plug in a huge number like 1 million. 1 million minus 4 over the square root of 1 million is positive. So this range is actually all real numbers. I want to see if I actually said that. Over here, yes I did. Okay. For this one, now odd roots have no stipulation that you have to stay positive. X minus 10 can be positive or negative. I can cube root negative 8, for example. I just can't square root negative 8. That's an imaginary number. So cube root, the only issue is that this is in the denominator, so x can't equal 10. Other than that, we're good. So the domain is negative infinity to negative 10, negative 10 to infinity. What about the range? I'm going to run through my same checklist. Can y equal 0? Yes. If x is negative 2, I get 0 over cube root of negative 12. So yes, y can equal 0. Can y be negative? X plus 2 can be negative. A cube root can be negative. So in either instance, if one of these is positive and the other is negative, I'll get some negatives. And x plus 2 can be positive, and so can x minus 10, or if they're both negative, yes, the y will divide out to something positive. So we're back to all real numbers for that. You might want to graph these just because they might look interesting on your graphing calculator, but you don't have to. Okay, and then we're skipping to 85 to 88. So let me just see if this is 85 to 88. We're doing difference quotient here. So find the difference quotient and simplify your answer. Excuse me. This first one uses C. I'm just going to use, I guess I can use C for the first one. So 85. Now, actually, I don't need difference quotient for this because this is a linear function. So I don't need the difference quotient. Remember, the difference quotient is equal to the secant slope. Excuse me. So what is the slope between any 2 points on the line 2x? The slope is equal to 2. Now, if you do the difference quotient, I guess I didn't do it, but if you do the difference quotient, if you do the work, you should get 2 in the end. Same thing with this one. This is linear. The slope between any 2 points on this function will be 3 because it's a linear slope. Now, if we have something that's not linear, so cubic or quadratic, we do have to do the difference quotient. So, all right, the difference quotient, the formula for the secant slope between any 2 points, is f of x plus h minus f of x all over h. There's explanation for why that's the formula in our notes if you need to go back and look. That means plug in x plus h into the function, so cube it plus 3 times x plus h. Subtract all of the original f of x, I always do it in parentheses. Divide the whole thing by h. There is a quick way to cube a binomial. This is called the binomial theorem. We have, if you've ever heard of Pascal's triangle, there's a better explanation, I'm sure, on YouTube, but you set up Pascal's triangle like this. You've got a single term. This could be like a plus b. Bring the 1 down here. 1 plus 1 is 2. This would be squaring a binomial. If I'm trying to do a plus b squared, I get 1a squared plus 2ab plus 1b squared. Next line will be for cube, so carry the 1 down. 1 plus 2 is 3. 2 plus 1 is 3. This last one is 1. So this would be for cubing. If you want to cube a binomial, 1a cubed plus 3a squared b plus 3ab squared plus b to the third. You could keep going with this. If I want to raise something to the fourth, I can. It's basically just a shortcut, so you don't have to keep distributing. So I'm going to use my cube. It's x to the third plus 3x squared h plus 3xh squared plus h to the third. Distribute this 3 through, plus 3x plus 3h. Distribute this negative through, minus x cubed minus 3x. Put the whole thing over h. If we have done our math correctly, all of the non-h terms should be canceling themselves out. So x cubed minus x cubed plus 3x minus 3x. Everything else has an h, which means I'll be able to divide it by h. So divide every term by h. And your formula for your slope of the secant line between any 2 points is 3x squared, that h divided out, plus 3x h to the first, plus h squared, don't forget about this guy, plus 3. H represents the distance between any 2 points. So you've got a point at x, and then you've got a point at x plus h. So if h is 0, if the 2 points have no distance between them, meaning it's a tangent slope now, you get 3x squared plus 3. If you know about derivatives, maybe you're in Physics C, the derivative of this is 3x squared plus 3. Anyway, more on that later. And I believe this is our last problem. So formula for our secant slope, I'm not going to write the general difference quotient. I'm just going to hop right into it. So x plus h squared minus the quantity x plus h plus 1 minus all of f of x all over h. Squaring a binomial we should have down by now, but again, use that binomial theorem if you need to. X squared plus 2xh plus h squared. Distribute this negative, minus x minus h plus 1. Distribute the other negative, minus x squared plus x minus 1 all over h. Check that every non-h term is canceling. Positive x squared minus x squared, minus x plus 1 minus 1. All of the remaining terms can be divided by h. So 2xh divided by h is 2x. H squared divided by h is plus h. Negative h divided by h is minus 1. And again, this is down the road we'll be talking about tangent slopes where we plug in, well, what if h is 0? Okay, then the tangent slope is 2x minus 1. And that's the work of finding derivatives. All right, if you have questions on this, please come to office hours or ask at the beginning of class.